So we've done the overview of the pop process. We've done the core pop process. Now let's look at, what happens when things don't go the way you hope. Okay. So let's do a little housekeeping. We'll close the waveform viewer, close and don't save the schematic. And let's go to topic 2.2.3, pop error messages. Okay. And let's go to schematic 2.8. So we're going to go to schematic 2.8, pop. And I'm going to hit my home key. All right. So let's run this. And what just happened? Now, we've seen this before. Hopefully this is somewhat familiar. We've seen this error before, but notice how fast it came up. Simplist didn't go off and ponder anything. It said right away, I got a problem here. You've asked for a pop analysis. You told me use a pop trigger, but I couldn't find a pop trigger on the schematic. You need to fix that. How do you fix that? Well, go to the part selector. So with elements, the part selector is always there. And then what we're going to do is go to the commonly used parts and the pop trigger device schematic device. Okay. So let's go to part selector, commonly used parts, and then we're going to scroll down to the next to last item under commonly used parts, which is the pop trigger schematic device. Now we also have a PFC pop trigger device that's for use with PFC circuits. What we want is just the basic pop trigger, so we can double click on that. You can either double click or you can click once. It brings up the symbol, click here once, and then that will do it. So now the question is, where do we hook this up? And we happen to notice, oh, this looks tempting. What's it connected to? Well, it's connected to the switch node. Okay, that sounds reasonable. One thing about switch nodes is that they're often very noisy. So you may have, depending on the thresholds and everything, you may have some double pulsing going on or just some ringing. These can be kind of poor, in general, they could be poor nodes to put the pop trigger. We'd like to have something that was a lot cleaner, like, for example, the clock that's generating the ramp, for example. But yeah, this will work. In this circuit, it works fine. So let's put it there and let's run it again. And it ran, but we wanted a pop analysis. Did we get a pop analysis? Well, we got this simulation health report, which is a smart error message. This is the literal error message that also shows up in the command shell. If you ever want to clear out the command shell, you can go to File, Windows, Clear Command Shell Messages, or you can do Shift Delete. Either of those work fine. Okay, but this is the error message that was just over here. And basically it's saying when a certain amount of time and there was no triggering event. So basically we hit the max period limit and nothing happened. So you need to fix this. Okay. All right. Well, what happens? What's the problem? Anybody have any ideas what the issue is? The input voltage is 12 volts. The threshold here is 2.5 volts. So this is switching, 12 volt switching. That shouldn't be a problem. What's the deal? All right, well, let's go.
The power switch has to be turned on before you observe a transition on the diode, no? Or...
Right. But it should switch at some point. Let's just look at our choose analysis. Anybody notice anything here? What's our maximum period? This is the default, by the way. 1 microsecond.
1 micro.
Yeah.
And
It's
what is our switching period? Our switching frequency is 500 kilohertz. That's a 2 microsecond period. So that's going to be a problem. So
3 micro then, yeah.
yeah, so what I like to do is I put in something that's, since this isn't variable frequency, we don't need to go too crazy, but I'll go 10%. Christoph can go 3. But remember, if I have those defaults set, I'm going to go to 100. My time domain, if I do 100 switching cycles, I'm going to go 100 times this far, with my, before the simulation finishes, if it is a problem. So I like to try to make this comfortably large, but not too large. Okay. So put in, 2.2, 2.1, I think our docs say 2.1. Yep, 2.1. I'm a 2.2 fan. Christoph could put in 3. Let's run it and see how that works. Boom. Okay, so now we got a steady state result. Okay. So key points to remember. You can mess stuff up. You can forget to put the pop trigger in there. You could have a mismatch between the levels. You can have it connected just to the wrong place. And then even once you fix those, you still may have an issue with the maximum period. So you got to look at that. And yeah, you will make the maximum period error guaranteed at least once per circuit. Guaranteed. Because you're in such a big hurry to get pop to work. Finally, I got my circuit working. Let's do pop. And then you forget to adjust that. Yes.
You would not recommend to put it, let's say, to a quiet node, not a power switching node as is shown on the schematic. Rather, the drive signal, for instance, or the clock signal would be a cleaner.
Something with a sharp edge. But you want something, ideally, you'd like something, as Chris mentioned, that's always switching. So the clock is always going to happen. I could have a set of initial conditions where, the error is such that, like, this is open loop, so it's not going to have a problem. But if I had a feedback loop, I may turn the switching off if I overshoot, for example, and that could defeat pop. But if I'm connected to the clock, then that will be more robust. But I want to do it on a sharp edge if I can. That'd be best. Okay.
I can say that I can say, Tom, I don't think in my whole career I have ever seen a malfunctioning pop trigger, though. It's always been very in terms of where I hook it, it seems to be relatively impervious to in most cases. You can give it hysteresis as well. You can add more hysteresis.
Yes, you can add hysteresis. So you have control.
I usually make that hysteresis large because it's typically a large transition, it's a large signal event. So
right, and so
all I care about is it hits some peak value and it goes to 0 or goes to some low value.
Right. So the large hysteresis gives you more noise immunity. That's a good point. Right.
And you could, in fixed frequency, you can put, the equivalent to the switching frequency as a source outside some inner circuit. When you don't have a pop trigger and you want to have something crisp and sharp, put it just a pop trigger and another source together outside, and you're done.
Yeah, I mean, we should probably mention to the users that Simplis is actually a fantastic analog tool. Even if you don't have a switching power supply, I use it all the time for PDN analysis, for example. If a customer sends me a circuit, I can make equivalent models, and especially if they send me complex models from let's say a Cadence tool or something, or they've downloaded them from Murata's website, then they get the really large value ones that have tons of L's and C's inside them. Just by providing a pop trigger, you can use it like you would a SPICE-like tool. As long as you provide the trigger, AC analysis works fantastic.
Yep.
And
so you can do exactly that. So I could have a purely linear circuit, not this one, but a pure linear circuit, no switching whatsoever, and just hook my pop trigger up to and I got to make sure that, I have my threshold set correctly. But now Simplis thinks this is a switching circuit. right? It's going to look here, see switching, it's happy, even if everything else is just R's, L's, and C's. It's very happy.
Yep.
And
So
so,
it makes it a fantastic tool for looking at filters and impedances, etc. Really, really good.